Okay, welcome to AZ Surg. I'm Colton Conan. Today I'll be giving a quick little talk on Log4j, appropriately named Log4Dayz. So, we'll get started. So, why this talk? This Log4j, hopefully everyone here has heard of it. Anyone security probably had their phone explode on December 9th when this event kind of went down, and the first shock waves of the exploit kind of rippled through the community. If not, you're going to learn. We're going to walk through the basic exploitation process, some other cool things we can do with it, its impacts, and just some general things to think about when dealing with this exploit. The other reason we were talking about it, the scope alone of this thing puts in the ranks of Eternal Blue, your MSO8s, your Shell Shocks, Heartbleeds, all your big name exploits, just because Log4j is massively used everywhere. The exploit caused irreparable damage to a lot of systems, and due to its sheer size, much like your Eternal Blue, you're going to keep finding this for probably the next couple of years. Definitely for the rest of this year, you're going to occasionally find this if you're working on pen tests on networks or stuff like that. So, still relatively new. I decided this talk a month ago, so it's a little bit older. We're about 2 months now. Well, just day over 2 months. So, very kind of important to be able to understand and go deep, take a deep dive on this. So what is Log4j? Well, Log4Java is the summarized term that everyone uses for Log4j. Java-based logging materially, pretty simple. Log4j2 is the standard at the moment. It is currently maintained by Apache. Log4j1 was the original version made by, names kind of slipped my head, but it was an individual programmer. Log4j2 came with a lot of improvements. Main thing being is it could write a lot more to logs. It was like a 16-fold increase. Log4j1 is end of life, as we'll get into later. You really shouldn't be using that at all. So, below is a quick little demo. I have a VM. We'll demo it a little bit, but below shows a simple hello world function, but at the bottom there's that logger.error. What that basically does is if no arguments are provided, it'll spit no data provided into the logs. Elsewise, it will error out. So, quick note on this: logger.error is not a proper documentation. Don't try to use this like this. You have to set up this like XML stuff. But this is just a quick little demo for us. So, one little interesting little quirk Log4j has, it has this ability to do lookups inside strings that are submitted through. Kind of similar to your format strings, your F strings in Python. You could use the $sign to denote, and then you can call a variable, and it will post that into the logs and do processing on it. So here's a quick example using the previous little snippet of code for the hello world function, where it takes the $sign Java version / $sign Java OS, prints hello world, but when it gets to the logging function, it will actually spit out the Java version and the Windows version. So we can leak Java-based variables through this, and as we'll get into in a moment, we can leak a lot more than just Java variables. One of the neat things you can do is you can leak environment variables, you can leak other based variables inside the program, and you can actually call specific functions, which is the next point. So the main issue is lookups can use JNDI. JNDI stands for Java Naming Directory Interface. To everyone here that's used Java is probably somewhat familiar with this, but for those that are unaware, the Java Naming Directory Interface is a way you can use it to call Java functions that are remote, and it will grab those classes or objects, and then it can run it on itself, kind of like pointing at services and whatnot. So the exploit that the original Log4j CVE talks about is you can use the Java name directory interface, make an LDAP query to a LDAP server. That LDAP server could be an LDAP referral server that points to an HTTP server. There's a diagram if this gets confusing for everyone. Talk about it in a second. That HTTP server can be hosting a Java.class object, which we can put into a reverse shell. App will go out and grab that Java class, which is conveniently a reverse shell to our attacking machine, and it will just run that code along with the project. So all you need is an LDAP referral server, HTTP server, and Java reverse shell. Pretty simple to set up. Demonstrate in a moment. To basically pwn systems and cause chaos using Log4j. So quick little diagram of it. I submit a object, a string or something to the vulnerable application server, whatever you want to call it, that contains the $JNDI LDAP call to my LDAP server. Then the application makes a referral to that LDAP server. LDAP server goes, hey, cool, you want to go to this object. This has what you're looking for. Then the server goes, okay, cool, goes to the web server, grabs that Java object, and then it starts running it, and we now own the system. So, pretty cool. So, one of the neat things that I saw while kind of researching this topic is one thing was on a Splunk site. It was talking about how you could search for your logs to see if a JNDI is being called by your objects, and it was just doing JNDI colon and then star afterwards to see what the internet spit it out. Well, there are tons of ways to bypass or even do a little bit of obfuscation. Here's some ones I stole from TryHackMe. You can actually call and nest inside lookups to be able to kind of hide what you're doing. So up here where you're calling the uppercase for J and DI, so it doesn't actually look like that. So Splunk isn't going to be able to find it. It's going to be kind of weird. It's going to have trouble trying to find it. The bottom one's probably my favorite because you're just called a bunch of flags that will be immediately converted to the characters. Tons of different ways. There's practically an unlimited number of ways to obfuscate it. So the classic meme of a whitelist is better than a blacklist in security can kind of be brought up here. So say we can't actually just cause our object to spit back a reverse shell to us using the Log4j exploit. Outbound tracking script, maybe there's some EDR that's sitting on this that is killing the application each time it's going. We can actually use Log4j to leak us environment variables back to us via a DNS server. So you can see on the bottom part, we're using the user environment variable. We go using the JNDI DNS function. We call our DNS server that we have control over, and then we can input our query for the environment user, and then just some garbage I have slapped at the end of that. And then if we review our DNS logs, we can actually see those environment variables getting leaked out. For this demo, I just use users, but we all know devs like to put things into environment variables that aren't really good to be environment variables. Maybe you got an AWS secret key or just passwords for no reason that are just sitting in there. Maybe it's even an SSH key. Like you can leak a lot of information now if you have access to all the environment variables of an application via Log4j. It gets better. Maybe your front point is patched. You got a good cybersecurity team. They came around, they patched everything up, put band-aids on everything. It's all good. Well, the problem with this is if Log4j if you can get a string of information to any system that has this vulnerability in it, it will do this process and reach out. So the example I give down here is there's a front end, has Log4j, doesn't matter, but it parses your data, throws in some backend database, and there your string kind of sits. Maybe the company has like an audit they run of some Java program every 6 months or so, and that Java program will go through the entire database. If you have a Log4j vulnerability, we can pop the execution, assuming it has access to internet, and we could have little time bombs just kind of hiding out through a network. So all kinds of neat little tricks we can do as we go through it. Does the function we enter the string have to be? Oh, yeah. So probably didn't explain that well earlier. Yes, anything that you log via string needs to get somehow logged into the Log4j or at some point processed in a place that's logging it. So, for example, Minecraft was one of the things like a chat. The chat is completely logged, but and that's how people were popping the exploit. And if you're a good person, you log everything, as good security people do. So, cause issues. So, the impact of this entire exploit was big to say the least. I was kind of lucky. Fun fact is, I stopped working at a SOC the week before this happened, and I can only imagine the panic that was going on over there because I know how many Java things they have running around that they don't know where they are at. But that would have been massive to say the least. There, to see it, SZA has a fucking list on GitHub. You can go down, read through. There is a surprising number of systems that are still affected with no patch at the moment. You can just go down the list. I did a quick little Control F search to see what systems are affected. There were still 500 systems on the list of like 3,000 machines. So, should tell you how big this vulnerability still is, and it's still becoming issues. Quick little highlight list of kind of the things you can see. Minecraft was patched, so don't worry about your Minecraft servers; they're all good. Palo Alto had some affected systems. They've patched all the ones in the latest releases, but old Palo Alto systems with the CLI, those are vulnerable to Log4j. Rockwell Animation, I'm like, oh, cool, a industrial control system provider. I wonder if they're patched. They won't tell me. So I went on their list, tried to find security advisors. I have no clue. Hopefully they're patched, but who knows? It doesn't say anywhere. It just says Log4j. So, yeah, Amazon too. Everything's dead. Splunk had a bunch of vulnerabilities, so just kind of pointing out some security companies, ICS, and everyone's favorite game. Fun thing about the whole Minecraft thing, a lot of servers got nuked during that weekend, so anyone that is a fun Minecraft fan will know that a lot of servers, public-facing servers, just got deleted off the face of the earth. So we talked about, so some of the big guys have all pushed their patches. Your small to medium-sized companies probably haven't pushed enough patches yet. We're still kind of in the early stages of this exploit. Like, all the big players have pushed patches and locked down their systems, but those medium and small-sized developers probably have systems that are still creeping around doing it. Uh, as I said earlier, this exploit is probably be seen well into for the next couple of years. It's probably going to become low-hanging fruit for attackers. They're probably going to start skidding it and just spamming that in scripts to see if it's vulnerable. And a lot of ransomware groups have weaponized this pretty quickly and have been using it actively to just get to as a way to load their malware into systems. Yeah, all types of fun things. So, quick little rundown mitigation, because everyone here will have to, if you find it, you have to explain how to mitigate it. Update your log4j libs. 2.17.2 is the latest at this time. 2.14.1 was the original one that was vulnerable. Every version between there then has a version of log4j that was vulnerable. They quickly found that log4j 1 also can get affected by the same exploit. It's not as severe as critical, but it's still like a 9 on the CVE scale, so it requires a non-default configuration, but it's still vulnerable, so please patch it. If you can't patch, here's a few workarounds that you can tell people, because devs, they really don't like to patch things up because it might break compatibility for some reason. Don't do this if you can. Just try to patch it. Force people to do this. You can give it a flag to say don't do lookups. That's pretty simple. Or my favorite, just yeeting the JNDI lookup class. Literally go into the jar file and just delete that thing, so it just doesn't work. Not a great solution because people are going to find things, and that just deletes the JNDI lookup class, doesn't delete the DNS. And maybe if they farther down the road they find more exploits and other ways to manipulate it, just patch it up if you can, and that's a pretty simple solution. And there's quick sources. I'll do a quick little demo on the vulnerability. I currently have the outdated version, 2.14.1. This also works in 2.15, but you have to use some other tricks, so I'm just using the basic version. Quick little Java run, cool. And you can see the logger. This is our example, Nevada prepare the log. So what we can do is we can do the lookups. I say java.runtime. Oh, of course I screwed it up. And there it spits out the lookup of the current Java runtime I have running on the machine. So what we can then do is we can do an LDAP lookup to complete the exploit to have full remote code execution. Don't have that set up at the moment, but this is kind of just to demonstrate to you how easy it is to exploit. All you have to do is just put strings in places and hope it's getting logged. And if that string gets logged by Log4j, it will cause the exploit to happen. So, any questions? Questions, anyone? Comments? Yes, that is League of Legends on bookmarks. I have an addiction. I need help. Okay, I think that's kind of the quick little notes on this, a quick little talk, just to give everyone a little bit of a quick talk on this. There's some more findings being discovered in other libraries for applications. Yes, to an extent. As I mentioned before, the Log4j 1, originally the vulnerability was discovered in Log4j 2. It was quickly discovered that non-default configurations of Log4j 1 had this vulnerability. I haven't heard of anything else in any other, not outside of Java at the moment, so I can guarantee there will definitely be some at this point, just because logging libraries are probably now under a pretty tight microscope after this one. It depends on how they handle lookups. So the question is, do you see this type of vulnerability affecting other programming languages? Depends. It's kind of Java specific on how this exploit works, because it's chaining together the fact that JNDI, you can submit JNDI remote requests through Log4j. If there is a similar mechanism in other programming languages, then yes, it could probably become an effect. But the whole point of this is that I can tell JNDI to look at a remote server that was not intended by the programmer. It will go grab that object, execute that object, and I have remote code execution. Yes and no. So right now, the patch has been, they have disabled JNDI lookups. You have to enable it by default. The best solution is to ensure that you know where your logs are coming from user input, and also to, again, don't trust user input. That's the golden rule here. Users can basically put whatever input they're in here, and that's what Log4j is logging, which is popping the JNDI. I think there is some more stricter rules on it in Log4j's library. So tell me. Stuff. So. Do you have a good resource for detecting JNDI lookup in a stem like Splunk? No, not off the top of my head. I saw there was a Splunk article on detecting it. One of the things I used right off the bat is this has kind of became the Bible probably for a bunch of sysadmins. They have details on looking up through Splunk, but there are ways to bypass the way Splunk has asked you to do it. Let me see if I can find it real quick for you. I'm just not streaming the right application. So the history behind that's a little convoluted, and the details are like strange and a weird part. The question wasn't one of the main issues that Log4j was not responsible for disclosure pyramid collected to ensure Apache compassion time. So the group that originally discovered it was a Chinese cybersecurity research group, and apparently they've been talking to Apache for some time. and they responsibly disclosed it on December 9th. However, there's plenty of evidence that suggests that it was being exploited in the wild, like December 1st. And if you go between the security articles, part of the reason I talk about it is it's kind of a convoluted mess of wires and tangles just to kind of get to the bottom of it. But some people are saying it was exploited before then. Some are saying as early as November. Some are saying it didn't happen until the 9th. It's kind of weird niche smashing stories. So I don't know what's true or not, but it did kind of just pop onto the scene extremely quickly. Back to the STEM one. Let me show you a third party. It's not. Are you kidding me? No, it's not loading it for me, and it did it again. Here it is. So Splunk had an article on how to search it, which is to use the index of seeing any JDI lookups. But again, you can do a bunch of bypasses or ways to obfuscate it, so that again you might not be able to see it in like Splunk or something like that.